People have been doing derivatives and edges for a very long time. The most classic one is referred to as the Sobel operator, named after Leonard. I have no idea. It's named after some guy named Sobel. And the Sobel operator looks just like what I was showing you, but instead of 1/2 and minus 1/2, it's got this weird thing where it's doing these eighths, and you can see that it does it not only +2 -2, which you would then divide by 4, and you'd get the same value, but it also does a +1 -1 on the row above me, and a +1 -1 on the row below me. And the idea here is that if I'm taking a derivative, remember how we said before we assume that our images are sort of locally smooth, that is, they change similarly. So the idea here is that if I'm going to compute a derivative at a pixel, I won't look just left, right at me, but I'll also look nearby me. And then to normalize this thing, you have to divide it by 8. By the way, having just almost finished teaching the course here on campus, we had a problem set where people were having a heck of a time that they hadn't had a problem with before. Turned out somebody had discovered that MATLAB has a built-in function called IM gradient XY. And they said, can we use that function to compute a gradient? Since it was for a part of a problem set that was more advanced and they had already done gradients, I said, sure. And all of a sudden people are having all sorts of problems. And the reason was, if you look up IM gradient, it tells you that it applies the Sobel operator by default. Well, here's the Sobel operator. Looks great. But you know what? It doesn't divide by 8. So all their gradients were scaled by a factor of 8. And it totally screwed up the entire class. 100 people got screwed up because of this. So now we tell them you can use IM gradient, but you better divide by 8. By the way, the y one is here as well. And in this case, y is positive going up. Remember, it could go in either direction. All right, so the Sobel gradient would just be made up of the application of this Sx and Sy to get you these values. And the magnitude is just the square root of the sum of the squares. I should have said that Gx is the application of Sx, Gy is the application of Sy. So the magnitude is just what we did before. And here's the arctan2, the atan2 that we were talking about in order to get the gradient. So here's an ancient example. It's so ancient I know because that's X Windows, so that even predates when most of you were born. And here you have a picture on the left that's an image. Here's a gradient magnitude, so you just apply the Sobel operator, take the sum of the squares, square root of. And then, by the way, you could just threshold it. And you'll notice two things. One, it's not an awful edge image. And two, it's not a great edge image. All right? So we're like partway there. Right? We're partly towards getting that done.